In this video, we will walk through how to get started with local AI image generation using Stability Matrix and ComfyUI. These are open source tools that let you run Stable Diffusion and most other popular AI tools and models entirely on your own machine. This guide is intended for people who are new to machine learning but want to explore what generative models can actually do, whether for creative work, academic research, or simply to understand the technology better. The focus here is practical, but with a good theoretical foundation. We will go through installing the software, understanding the interface, and getting your first images generated, all using tools that are completely free. Before we begin, there are a few technical requirements worth noting. Unlike browser-based AI tools that offload processing to remote servers, everything here runs on your own hardware. That gives you full control, but it also means your system needs to meet a few minimum requirements. Apple users should be aware that only devices with an Apple Silicon chip like an M1 or newer are supported. Intel Macs are unfortunately not compatible. Now, you can run these tools on a mid-range laptop, but keep in mind that performance will vary. Generating a single image on something like an NVIDIA RTX 4060 laptop might take a few minutes. A high-end desktop with an NVIDIA RTX 4090 will do the same in seconds. Here you can see some examples of generation times on different GPUs. Note that if the VRAM of the GPU is insufficient, like in the case of the Huawei MateBook X Pro, the model is offloaded to the CPU, which can increase generation times a lot. The good news is that everything we're using here is free and open source, so you can test it yourself and see how your system performs. Before you download anything, you should also be aware of potential security issues. All the tools we discuss in this video have their code online for anyone to review. They are generally trusted in the community, but it can always happen that security risks are accidentally introduced through updates. Thus, follow this tutorial at your own risk and always make sure to use trusted sources. Now we can get started by setting up Stability Matrix, which is the platform we will use to install and manage ComfyUI along with various models and tools for image generation. Stability Matrix is a free open source tool developed by Lycos AI, a trusted contributor in the AI community. You can think of Stability Matrix a bit like Steam, but for local AI tools. Just as Steam provides a unified platform to download, launch, and manage video games, Stability Matrix acts as a central hub for installing and running open source AI software like ComfyUI on your own machine. It handles the heavy lifting of managing dependencies, models, and configurations, making it easier to get started without going through all the technical setup steps manually. To get started, just download the pre-built version of Stability Matrix from the official website or GitHub project. It's available for Windows, macOS, and Linux, and comes packaged as a zip or DMG file depending on your operating system. A quick note about storage. Stability Matrix itself doesn't take up much space, but the models you install and the images you generate can quickly grow into tens or even hundreds of gigabytes. If you have limited storage, it can be helpful to run Stability Matrix from an external solid-state drive. For example, this tutorial was tested using a SanDisk Extreme Portable Pro, which offers fast enough speeds for this kind of work. Also, make sure not to put the application into a cloud storage folder like OneDrive or iCloud. This can prevent Stability Matrix from running correctly. Once downloaded and moved into a suitable folder, we can get started with running Stability Matrix for the first time. It's important not to run the program directly from the archive. Always extract it first. On Windows, you should see the option Extract All once you single-click on the zip file. On macOS, you can simply double-click the DMG file. On Windows, after you unzip the file, you can simply delete the zip archive you've downloaded in order not to get confused about which to open later. Then you can open the unzipped folder. Inside the folder, you will find the application file. On Windows, it's an exe file, usually named something like stabilitymatrix.exe. Depending on your system, you may see a security warning. On Windows, for example, you will likely get a message saying that this is an quote-unquote unrecognized app. You can click more info and then run anyway. On macOS, you may also have to follow the standard procedure for installing an external app. After dragging Stability Matrix into the system's applications folder, double-click the Stability Matrix icon. This will probably tell you that it cannot open the app. Then click the Apple menu, go to System Settings, and then find Privacy and Security in the sidebar. After you scroll down, you should see an option to open the app. Once Stability Matrix launches, you will be asked to choose a setup mode. I recommend selecting Portable mode. This keeps everything self-contained in one folder, and if you ever want to uninstall it later, you can just delete that folder or move it to a different location. After that, you will see a screen asking whether to share analytics. This is optional. I usually go with Don't share analytics to keep things private. Next, Next, you will be prompted to choose a Stable Diffusion web UI. This tutorial focuses on ComfyUI, so go ahead and select that option. You will then be asked which models you'd like to download. For now, you can skip this. Just don't select anything and click download. This will install only the interface, which is all we need at this stage. The download might take a few minutes depending on your connection. You can click hide to minimize the screen and it will continue running in the background. You can see the progress in the lower left corner of the app. While ComfyUI is installing in the background, this is a good time to take a closer look at the Stability Matrix interface. Stability Matrix is designed to be a user-friendly environment that helps organize your local AI tools. You'll find the main navigation menu on the left-hand side of the window. If the labels aren't visible, click the 3-line icon to expand the menu and reveal section titles. The Packages section lists all tools and interfaces you have installed. This will include ComfyUI once installation is complete, and optionally other tools like OneTrainer, which is used for training AI models. If you want to install and explore other tools later, click Add Packages. You will see tools grouped into 2 categories: inference tools, which are used for generating images, and training tools, which are used for tasks like model fine-tuning. The Inference tab allows you to generate images directly inside of Stability Matrix. However, I recommend using ComfyUI instead. It offers a more flexible interface and far more control over how images are generated. The Checkpoint Manager is where you will find all the models you've downloaded so far. This includes full models like Stable Diffusion and optional add-ons like LoRa's and control nets. It's essentially your model library. From here you can keep track of which models are valuable to your tools and stay organized as you begin working with more advanced configurations. Next, let's take a look at the model browser. This is where you can download additional AI models to use with tools like ComfyUI. Stability Matrix connects to 2 major model repositories, Civet AI and Hugging Face. Civet AI is a community-driven platform where users share models they've trained or customized. You will find a huge variety here, including experimental styles and niche aesthetic models, but it's important to note that Civet AI is minimally moderated. Some models may contain explicit content or ethically questionable material, so I would recommend approaching it with care, especially if you're working in a professional or institutional setting. The second source is Hugging Face, which is widely respected in the AI space. It hosts both official models like Stable Diffusion XL and a range of tools often used in advanced workflows such as ControlNet and Clip. If you want to go with the original models, you can stay in the Hugging Face section. For this tutorial, we will use Stable Diffusion models. Stable Diffusion is one of the most common AI models that has been around in different iterations for years. More recent and advanced models have come out since then, but they can be a bit more complicated to get started with and usually require much more powerful hardware. So Stable Diffusion remains one of the easiest ways to get started with local AI image generation. As mentioned, Stable Diffusion comes in a few versions. The most common ones are Stable Diffusion 1.5 and Stable Diffusion XL, which you can also see in the Hugging Face section. Stable Diffusion 1.5 is the earlier version, which was trained on images with a resolution of 512 by 512 pixels. Thus, it can only reliably produce images with the same resolution. The generated images can lack detail, but generation times are faster due to the low resolution. So if you don't have the most powerful device, this might be the most convenient option for you. On the other hand, Stable Diffusion XL was trained on 1024 by 1024 pixel images. Thus, the generated images usually have more detail. At the same time, generating images takes longer and requires more powerful hardware. For this tutorial, we will go with Stable Diffusion XL, but if the generations are too slow on your device, feel free to go back to the model browser and download a Stable Diffusion 1.5 model. To download a model from Hugging Face, just click the checkbox next to it, then press the import button in the bottom right corner. The model will be installed directly into your Stability Matrix environment. Once it's downloaded, it will be available in the Checkpoint Manager and ready to use with ComfyUI or any other interface you've set up. These base models available through Hugging Face would usually be perceived as lower in aesthetic quality compared to fine-tuned models. If you're interested in such fine-tuned models, you can go back to the Civet AI tab and search the wide variety of community-made AI models. Here it can be helpful to use the filter options to make sure that you download the appropriate type of model. The most important filters are the model type and base model. When you click on model type, you see a list of options. For this tutorial, we are looking at so-called checkpoint models. These are full models capable of generating images by themselves. Most of the other options are additional models that you can include in your workflows. We will cover them in future tutorials. Under the base model section, you can see see a lot of different tags. These describe which model has been fine-tuned by the user. For the moment, we only need two options. If you want to use Stable Diffusion 1.5, select SD 1.5. And if you want to use Stable Diffusion XL, select SDXL 1.0. If you've already heard of a specific model, you can also use the search function to find it. A popular Stable Diffusion 1.5 model is called Dreamshaper, and Juggernaut XL is a popular Stable Diffusion XL model. I've personally been using the Zavichroma XL model quite a bit. Here you can see the type and base model on top of the model card. When you click on the model, you see its different versions, the download location and a model description. Sometimes the person who trained the model will recommend settings for generating images. You don't have to understand all of these settings yet, but you will probably have a better understanding of what these mean by the end of the video. Once you've decided which model version you want to use, you can click the import button, which will download the model and make it usable for ComfyUI later. The next section is the output browser. Once you start generating images with ComfyUI or any other inference tool inside of Stability Matrix, you will find your results here. If your images don't show up here for some reason, don't worry, we will cover how to locate them manually in your Stability Matrix folder later. Lastly, the Workflows menu gives you access to community-made ComfyUI templates. These are pre-configured setups for specific tasks like image-to-image generation or more experimental pipelines. For this tutorial, we won't be using this feature, but if you're more advanced or curious about building reusable processes, it's a helpful resource you can explore later. As you start working with Stability Matrix, it's helpful to understand how the folder structure is organized. This gives you more control, and it's especially useful when generating images, managing models, or making manual adjustments. If you followed the recommended portable installation, you will find a folder called Data inside the main installation directory right next to the executable you use to launch the app. On macOS, the structure is nearly identical, but the data folder will typically be located within the applications directory. Here's a simplified breakdown of the key folders you will see inside the Stability Matrix directory. The assets folder contains internal components like a portable version of Python. You won't need to touch this usually. Images is where your generated images are saved. If you are ever unsure where your outputs ended up, start here. Note that some tools like ComfyUI may also save images inside their own folders, for example, data, packages, ComfyUI, output. The models folder is where Stability Matrix stores all your downloaded models. Inside you will find subfolders for different types. Most important is the Stable Diffusion folder for your checkpoint models like SD 1.5 or SDXL. You can also add models manually. As long as they are placed in the correct subfolder based on type, they will automatically show up in ComfyUI. In the packages folder, each application you install like ComfyUI or OneTrainer gets its own folder along with its internal files and configurations. Portable Git contains a portable version of Git, which is used internally by Stability Matrix to manage code and updates. Like the assets folder, you usually don't have to interact with this directly. Understanding the structure will make it easier to locate files, manage your assets, and troubleshoot if anything doesn't behave as expected. It also gives you more flexibility if you want to customize or move things manually. After ComfyUI has finished installing and once you've downloaded a checkpoint model like Stable Diffusion XL, you're ready to launch the interface and generate your first images. Start by navigating to the Packages tab on the left-hand side of the Stability Matrix interface. Here you will see a list of installed tools, including ComfyUI. Next, click Launch on the ComfyUI card. This opens a terminal window inside Stability Matrix and starts the local server. After a short wait, you will see a message like this. That means ComfyUI is now running locally on your computer. Next, click the Open Web UI button at the top of the terminal window. This opens the ComfyUI interface in your default browser. To clarify, ComfyUI runs entirely locally. Even though it opens in your browser, it's not connected to the internet by default. The address 127.0.0.1 is also called localhost, which means everything is processed on your machine. You can test this by turning off your internet after downloading and installing everything. ComfyUI will open and work just the same. When ComfyUI opens for the first time, you will see something like this, a visual layout of connected blocks, or what ComfyUI calls a workflow. ComfyUI works through nodes, each representing a specific task in the image generation process. You can think of it like a flowchart that shows exactly how your image is built step by step. This This structure is what makes ComfyUI so powerful. It's a modular system that shows you what kind of operation is happening at what point of the workflow. Behind the scenes, these nodes are written in Python, a very common programming language, which means that they can be extended for all kinds of tasks. While ComfyUI is focused on image generation, the system is capable of much more, whether it's generating sound and video or doing file conversion and maths. ComfyUI also supports community-made custom nodes, which you can install to unlock additional features. However, this tutorial sticks with the default nodes, which are most stable and safe to use. If you are new to the system, I would recommend being cautious with community nodes. Some are excellent, but they may also affect performance or introduce security risks. Now that ComfyUI is up and running, we are ready to generate our first image using the default workflow. If your interface already shows a workflow, you can use that, but if not, or if you made changes and want to reset the workflow, you can easily reload the original setup. At the top of the interface, click on Workflow and then choose Browse Templates. From the list that appears, select the first example called Image Generation. This loads a simple, pre-configured workflow designed to show the basic image generation process. It includes everything you need to produce your first output. Before we generate an image, let's walk through all nodes in this default workflow. We start with the Load Checkpoint node. This is where your model is selected, either Stable Diffusion XL or Stable Diffusion 1.5, depending on what you downloaded earlier. These options are pulled from your system's local model folder, specifically Data, Model, Stable Diffusion. First, we follow the outputs going into the clip text encode nodes. These convert your prompts into a format that AI can use. The top node is for your positive prompt, which defines what you want to see in the image. The bottom node is for the negative prompt, which defines anything you want to avoid. Each model and fine-tuning will interpret prompts differently, so there is no single rule on how to write a good prompt. Generally, it's a good starting point to use some keywords like objects and styles mixed with phrases that describe the image you want to generate. Sometimes you can also find useful keywords or prompts in the model description on Civit AI. One important note for the negative prompt is that you should not use already negated phrases such as no clouds. Just list the undesired item like clouds without the word no. That is because Stable Diffusion works by generating two versions of the image, one from the positive prompt and one from the negative. Stable Diffusion then subtracts the negative image from the positive image. This applies to both Stable Diffusion 1.5 and Stable Diffusion XL. Other models might either not use negative prompts or treat them differently. Both of these clip nodes output conditioning data, the orange wires, which feed directly into the KSampler where the actual image generation happens. Before the KSampler, we have the empty latent image node. It provides the starting noise, the so-called latent image from which the final result will be built. We will talk about what this noise means later. For the moment, we just have to know that we can configure two parameters with it. For one, we can change the resolution of our final image. For two, we can change the batch size, meaning how many images you want to generate at once. You can technically enter any resolution here. However, in practice, this setting significantly impacts the quality and structure of your image. As mentioned earlier, each model was trained on images of a single resolution or a range of resolutions, which means it's optimized to perform best at that size. If you're using SD 1.5, set this to 512 by 512 pixels. If you're using SDXL, set it to 1024 by 1024 pixels. If you use a mismatched resolution like 512 by 1024 pixels with SD 1.5, the model can produce strange artifacts. A common example is duplicated features like two heads stacked vertically in a portrait. That happens because the model tries to fill the additional space effectively tiling its 512 by 512 pixel knowledge to fit the new shape. Some non-square formats still work reasonably well, especially those close to a 1:1 aspect ratio. For example, the common social media ratio of 4:5 can work nicely with SDXL. Newer models like Stable Diffusion 3.5 or Flux are trained on more varied datasets and handle flexible resolutions better, but even these models tend to have a preferred range. For now, set your resolution to match the model you're using. Next, we arrive at the KSampler, which is the core of the generation process. This is where the image is actually created. The KSampler takes three main inputs: positive and negative prompts via the clip nodes, the model from from the load checkpoint node, and the latent image, which provides the resolution. These inputs combine to define the conditions under which your image is generated. Let's walk through the settings inside the KSampler from top to bottom. The seed determines the starting noise. If you use the same model, same prompt, and same resolution, and also keep the seed the same, you will get the exact same image every time. Change the seed by even one digit and you will get a different image. The second setting controls what happens to the seed after an image is generated. By default, it's set to randomize, meaning every time you run the workflow, you will get a new numeric seed and thus a new result, even if you don't change anything else. This is useful for experimentation or when you want variety without adjusting anything manually. You can also choose increment or decrement to adjust the seed by 1. The fixed seed can be helpful when you want to run tests. If you want to see how the other values impact the generation, you can keep the seed fixed to isolate the impact the other parameter has. The next important parameter in the KSampler is called steps. This controls how many denoising steps the algorithm takes to generate the final image. You can think of it like this. Stable Diffusion starts each image generation with a canvas full of random noise. Each step removes some of that noise, gradually revealing the image described by your prompt. In general, more steps means more detail. Fewer steps often lead to blurry or underdeveloped results. But keep in mind, the improvement isn't linear. After a certain point, adding more steps can actually start to degrade the image. If there's no noise left to remove, the algorithm will start to reduce details from the image again. For Stable Diffusion 1.5 and SDXL, most workflows use between 30 to 80 steps. That usually gives you a good balance between speed and image quality. Just be aware, more steps also means longer generation time. This can matter a lot if you're working on slower hardware or generating multiple images in a batch. One way to approach it is to do early testing or quick previews with a lower number of steps, maybe around 20. Once you're happy with the setup, increase the steps for a higher quality final result. If you really like the composition of an image with few steps, you can also keep the same seed and do another run with more steps. This will keep the first 20 steps basically the same, generating the same image, but it will then add detail with the additional steps. Next, let's look at the CFG value, which is short for Classifier Free Guidance. This setting controls how closely the AI sticks to your prompt. In simple terms, a low CFG value lets the model interpret your prompt more loosely. A high CFG value forces the model to follow your prompt more literally. In this interactive example for the prompt Panda playing guitar, we can see how with low CFG values, the AI generates things in addition to the original prompt, like the background. The higher we put the value, the more it focuses on the literal prompt. For models like Stable Diffusion 1.5 and SDXL, the sweet spot is usually somewhere between 5 and 12. Too low and the image might not reflect your prompt, too high and you might start seeing weird colors and textures. Different models respond differently to CFG values. Newer or fine-tuned models like Lightning, Stable Diffusion 3 or Flux may use the CFG value differently or do not use it at all. So there's no perfect CFG value. It depends on your prompt, your model and your goal, whether you want a flexible interpretation or something very specific. If you want to understand how CFG affects your image, try setting a fixed seed and changing only the CFG. That way you're isolating this one variable to see how it shapes the output, as we see in the interactive example. The next two settings in the KSampler are a bit more technical, the sampler and the scheduler. These define how noise is removed during image generation. As we've discussed, Stable Diffusion starts with pure noise and gradually refines it into an image step by step. The sampler determines the mathematical method used during each of these steps. Think of the sampler as the model's strategy for shaping the image. Some samplers are faster and good for general use, like Euler, which is the default. Others like DPM++2M Keras are slower but can produce finer details. Even if you keep the number of steps the same, generating time can vary a lot depending on which sampler you use. The scheduler defines how the sampler is applied across the steps. In other words, it's the pacing or structure of how noise is removed. Most of the time the default setting, normal, is a great place to start. But other options like exponential can produce noticeably different images and are worth exploring as you gain confidence with the image generation process. Some fine-tuned models may recommend specific sampler and scheduler combinations. If that information is available, it's usually worth testing. This is also what we've been seeing earlier when checking the model description for Savichroma XL. For now, feel free to leave both the sampler and scheduler at their defaults. The last setting in the KSampler is Denoise. This defines how much random noise the model starts with. In a a text-to-image setup like the one we're using now, it should always be set to 1. This tells the model to start from 100% noise, which is necessary to generate an image entirely from your prompt. In image-to-image workflows, denoise acts like a blending control. A value of 0.7 means the model starts with 70% noise and retains 30% of the original image. Lower values preserve more of the source image, higher values introduce more randomness. But in our case, where we are generating an image only from a prompt, denoise should always be set to 1. Setting it lower will usually result in incomplete or broken outputs. And that wraps up all the settings inside the KSampler. You've now seen how each part from seed and steps to sampler, CFG and denoise contribute to the final image. After the KSampler finishes generating the image, the data passes through one more critical step, the VAE Decode node. This node is responsible for converting the model's internal output, called the latent image, into a final viewable format like PNG or JPEG. The latent space is a kind of compressed mathematical version of the image. It carries all the information, but not in a way we can view directly. You might notice that the preview inside the KSampler can look a bit off, grainy or oddly colored. That's because it hasn't been decoded yet. The VAE decode translates this latent data back into pixels. You don't need to understand how VAEs work mathematically. For this tutorial, it's enough to know that this node is essential before being able to see or save the final output. The last step in our workflow is the Save Image node. This is where your fully rendered image is displayed and saved to your system. This node automatically saves your image to ComfyUI's default output folder, which should be set to the Images folder in Stability Matrix. Otherwise, you will find it in the ComfyUI output folder. If you want to set a custom file name or save location, you can do that here, but be sure to make those changes before you run the workflow. One very convenient feature of ComfyUI is that the entire workflow is embedded in the PNG file. So if you generate an image and later want to reuse the workflow or check the seed it used, you can simply drag and drop the image into the interface. Sometimes you may not want to save every image. In that case, you can swap out the Save Image node with the Preview Image node. Either right-click the node and choose Remove, or select it and press the Delete key on your keyboard. Then you can double-click on any empty area of the workflow. This will open up a search function for all nodes available. Here you can search for Preview Image and click it to insert the node. Then simply connect the VAE Decode's image output to the image's input. Now the generated image will not be automatically saved, but you can manually save it with a right click on the node. Another way to connect a new node is by deleting the connected node and simply dragging and dropping from the output of the previous node into empty space. This will give you some compatible nodes and also the option to search for other nodes. Now that your workflow is fully set up, from loading the model to saving the image, you're ready to generate your first results. Simply click the Run button. This queues the workflow and begins the generation process. Depending on your hardware and step count, it may take a few seconds to a couple of minutes. Next to the Run button is a small numeric field. By default it's set to 1, meaning the workflow will be triggered one time. You can increase this number to generate multiple images in a row using the same settings. You now have all the essential tools to generate, refine and save AI-generated images locally using ComfyUI and Stable Diffusion. This workflow gives you a powerful and flexible foundation for creative work, and it's also the first step towards more advanced uses like training your own models. If you want to see more examples and workflows, you can check the live streams on my channel where I walk you through this and more advanced ComfyUI setups. Also make sure to like and subscribe to never miss a new video, and I will see you in the next one.